Let's discuss structures and functions part 5. In the previous presentation, we have learned how to return a structure variable from the function. Now in this presentation, we will learn how to return a pointer to a structure from the function. Here we are directly considering the program. I want you to understand this program very carefully, okay? There are certain points which we need to understand in this program. Here you can see we have to start with the main function, just act like a compiler. So we know that compiler starts from the main function no matter what the code has been written. So let's start with the main function. Within this main function, you can clearly see I have declared two pointers, ptr1 and ptr2. You can see over here their types are struct point. That means they will point to a struct point type of data, right? So ptr1 will point to data of type struct point and ptr2 will also point to data of type struct point. After this, I'm calling this function fun, and here I'm passing these two arguments 2 and 3. You can see the definition of this function. Here these two variables will receive these values. A will receive 2 and B will receive 3. We know that after calling the function, control will transfer from this point to this point. Now let's go along with the flow. Here let's consider this fun function. Within this fun function, you can see this statement over here. I want you to focus on the statement very carefully. You might be wondering why I'm calling this malloc function. Malloc function is used to allocate memory at heap. Why we want to allocate memory at heap? You will understand that in a moment. But let me tell you, this is very important step. I'm allocating here memory at heap. You can see over here the parameter that has been passed to this malloc is size of struct point. This means that I'm asking malloc to allocate the memory of size equivalent to the size of this struct point. You can see over here this is struct point which consists of two members x and y. I want the malloc to allocate memory of size equivalent to the size of struct point. After allocating the memory, malloc will return a pointer, right? And that pointer is basically a void pointer. But I need to typecast it to a correct type. That is why this typecasting is required here. Struct point star. Now what does it mean? Malloc is returning a void pointer, right? As the data we want to store in that memory is of type struct point. That is why the pointer must be typecasted to struct point type. This is very important because that pointer will point to a struct point type of data which has been allocated at heap. That is why that pointer must be of type struct point. And here you can see the PTR will receive the address of the first byte of the memory, and obviously as it is pointing to a struct point type of data, that is why its type must be struct point. So this step is very important. You can understand that what is our requirement and why we are typecasting it in this way. Now let's see the second step over here. This is PTR arrow operator x equal to a, and this is PTR arrow operator y equals to b plus 5. Now this is interesting. Here, with the help of PTR, we are calling the members of this struct point. We can do that because PTR is the pointer which can point to struct point type of data. So here we can see struct point consists of two members x and y, and with the help of arrow operator, we can access these members very easily by using this PTR pointer. And here what we are trying to store the values stored in these variables a and b. A contains 2 and b contains 3. That is the initial case, right? We are calling this fun function, we are passing 2 and 3 to it. So obviously a contains 2 and b contains 3. 2 has been passed to x and 3 plus 5 has been passed to y, which means that after these two steps, x contains 2 and y contains 8. As simple as that. Here you can clearly see this time the values has been stored in the heap, right? Because PTR is a pointer which is pointing to a heap memory and not a stack memory. So it should be very clear that here we are passing the values to the heap memory. And what I am doing here, I am returning the pointer. And you can see over here the return type is also struct point star, right? Obviously we are returning a pointer of type struct point, so it should be struct point star. Now this is the point where we should understand why this malloc function has been called, why we are allocating memory at heap. Here we are returning a pointer, right? The simple justification that why I am using malloc over here is that heap memory is fixed. As simple as that. The memory allocated at heap remains fixed. We have to explicitly deallocate it. Remember that? Stack memory automatically get deallocated. But heap memory will not. It will remain intact. So the memory allocated at heap will remain as it is, and that is why we can easily return the address of the first byte of that memory without any problem. Because that memory is fixed, and even after the function finishes its execution, the memory remains intact. It will remain in its place. Okay, that is why it is very important to allocate memory at heap. You should understand the end goal. We want to return a pointer, which means we want to return the address of some memory. We know that the stack memory automatically get deallocated. We can understand that these two variables get automatically deleted after the function finishes its execution because these two variables are local to this function. They have been allocated stack memory. When the function finishes its execution, these variables get automatically deleted. This is the reason why we have to use the heap memory, because we want to return the pointer. In that case, the memory should remain intact, and this is not possible with stack memory. That is why we are taking the help of heap memory. After returning the address, this address will get stored within this PTR1. Now you can understand that PTR1 also has the capability to access these variables x and y. Note the data type of this PTR1, it is struct point star. You can understand that PTR1 can also access these members x and y, which contains value 2 and 8. So here PTR1 is nothing but pointing to a heap memory which contains two values 2 and 8, and they are the values of x and y. Now after this we are calling fun function again, and this time we are passing different values to these variables a and b. There's no problem at all. A new memory has been allocated by malloc, and here in these x and y variables we will store 6 and 9 plus 5, which is 14 respectively. And after that we can simply return the address, and that address will be stored within this PTR2. Now the PTR2 is capable of accessing the variables x and y, which contains the values 6 and 14. And you can see over here I'm calling this print function, and here I'm passing PTR1, and within this print function we are calling a printf function, and we are accessing the values of x and y. You know the values of x and y. These values are 2 and 8 because we are passing PTR1 and not PTR2. So the output in this case will be 2 and 8. Again we are calling print function, and this time we are passing PTR2, and we know the values of x and y associated with PTR2. They are 6 and 14. And after that you can clearly see I am calling this free function, which means I am deallocating the memory. That is why I am saying when we allocate memory at heap, it is our responsibility to deallocate the memory. So the output of this program is obviously 2, 8, 6 and 14, right? Okay friends, this is it for now. Thank you for watching this presentation.